Okay, in this video we're going to start our part one of laws of exponents. And first one we're going to learn is when the bases are the same. These are our bases right here. This is the base and this is the base. The actual exponent is the actual subscript number or letter that's up above the base. That is actually called our exponents. We also call this a power sometimes, like to the third power or the fourth power. All right, so how do we do this? So whenever the bases are the same, so otherwise they're the exact same number or a variable, then we can add when we're multiplying. And remember, we got to really pay attention to what operation, because we could have many different operations. But if that operation shows that it's a times between the two, then we just simply add the m and the n together. All right, so we keep the base the same. So let's do one. Let's say that we have three, let's make it a variable so that way it makes it easier for us. Let's say we have a to the fourth times a to the sixth. Well, we have a's, the bases are the same, they're both a's, and we just say 4 plus 6, and we say a to the 10th power. That means we have 10 of these guys. We have 10 of them. That's what that means. All right, so anyway, so let's do one where we have a few numbers. All right, so let's say that we have 3 to the third power times 3 to the second power. All right, so what this means is that my bases are the same. I can add my exponents. So it's 3 plus 2 is 5. So it's 3 to the fifth power, which is really 3 times 3 times 3 times 3 times 3. And of course that's 9, that's 81. And so 81 times 3 is 243. All right, so here's one I got for you. Let's see if you can try this. All right, in this case, could I do this? What's the first thing you notice? If you notice, my bases are not the same, so I can't add the exponents. We only can do it if the bases are the same. To solve this problem, we would say 3 to the third power is really 27, and then we could say 4 to the square is 16, and then we can multiply these two numbers together and get a whole number. All right? What if I had something like this? What if I had something like this? Could I make an exponent out of them? Well, let's think about this. 8 is really 4 times 2, which is 2 times 2 times 2. All right? And I have 2 of those, so that means I have this many of those. So I really have 2 to the 6th power. All right? And if you want to check it, you can take your calculator, where 2 to the 2nd power is 64. 2 to the 6th power would be 2 times 2 is 4. 2 times 2 is 4. That's 16 times 4 is 64. So it would equal 64 as well. All right, what about 4? 4 to the third power. Well, that's the same thing as saying 2 times 2. But I have 3 sets of those, so I have this. So in this case, I have 2 to the 6th power. Notice I made the bases the same. So really now the bases will be 2, and I add the exponents, 2 to the 12th power. And I can get this exponent that way too. And I could expand it and get my answer as well.